All right. So, guys, today we're going to be looking at 2.2, as I'm sure all of you are already aware of since you're clicking on the video. So let's go ahead and dive right into it. So, 2.2, standard form of a line. So, in math, there's all different kinds of names for different forms of the same equation, basically, right? Mathematicians just decided to make lots and lots of different types of forms for things, and the forms typically have each form has an advantage over another type of form, right? So slope-intercept's advantage was that it could tell you the slope and the y-intercept immediately of a line, right? But today we're going to be converting to standard form and then going from standard form to slope-intercept form, just to practice. Because standard form's advantage is that it can find x and y intercepts of a line very quickly, right? Particularly the x-intercept. I know the slope-intercept also gives you the y-intercept. The slope-intercept form also gives you the y-intercept quickly, but standard form can give you both intercepts pretty quickly. So then we're going to find equations of parallel and perpendicular lines. All right, so we'll define parallel and perpendicular. Well, we'll give loose definitions here, and then figure out how to use those to find equations. So you should go ahead and write this down up here, and you should not write this stuff down over here, all right? Because we'll get into all that. So let's have at it. So the standard form of a line is always in this form. That's what makes it standard form. It has to always be in this form. And that is where your x term and your y term are on the same side of the equal sign, and you're equal to some number. So comparing that to slope-intercept form where it had your y by itself with nothing in front of it equal to some number of x plus some number, right? That was like slope-intercept form, where your y was by itself and the coefficient in front of it was 1. You had 1y, and then the rest of everything else was over here. Well, standard form is where you don't need to get y to be by itself, you don't need to get x to be by itself, and you don't even need the coefficients of them to be 1. So long as your x and your y are on the same side and it's equal to a number, you are in standard form. And a, b, and c are just numbers, right? So let's convert the following equation to standard form. Right now this is in slope-intercept form, right? You got y equals 16x minus 3. What we want to do is to get it in standard form is get the x and the y on the same side of the equal sign. So what we need to do is we need the number to be by itself. So this number needs to be by itself. So we need to move the 16x. So subtract the 16x to the other side. And this is definitely allowed. And all you'll do is you'll have negative 16. Actually, what color do I want to use today? Let's see how this comes through. Negative 16x. Because we subtracted it, right? So it's over here as a negative 16x. And then plus your y is equal to, right, so this canceled, equal to negative 3. All right, that's it. That's your problem in standard form. You just move the x term. So here, on this next problem, it's the same thing. You need to get this negative 7 to be by itself on the equal sign, right? The c is by itself up here, so negative 7 needs to be by itself over here. So you need to take this and move it to the other side. And to do that, you want to, since this is a negative 2/3 x, you want to add 2/3 x. And that's totally allowed, because if you had a negative 2/3 x and you added 2/3 x to it, they cancel out. You want to add 2/3 x over here, and you will get that 2/3 x plus your y, because that y stays here, equals negative 7. And that's it. We have converted from slope-intercept to standard form. It's like a one-step process. All right, so make sure you guys have written this down, and we will move on. So now we're going to convert from standard form to slope-intercept form, and all of this stuff is like, it can serve multiple purposes depending on the type of person you are. If you're really stuck in your ways and you only want to graph in slope-intercept form, then you'll need to know how to do this. If you're flexible and you can graph in either form, then you won't technically need to do this whenever you're graphing. However, this is like also good practice at manipulating equations. So that's the main reason I'm giving this to you, is so you can practice manipulating equations. All right, so here we've got a standard form equation, and we want to put it into slope-intercept form. And what that means is that your y needs to be by itself. You need to solve for y. So you take this and you want to solve it for y. That's basically all we're doing. And you'd be surprised how many students forget about, like they have trouble learning this, and they forget about it halfway through the year, right? So it's just basic equation manipulation here. So this is the term you want to get by itself for now, because you're trying to get y by itself. So you don't plug anything in for x. X is not going, x is not going to disappear. It's still going to be in your equation, right? A lot of students think, well, if I need to solve for y, I can't have an x in my answer. Well, you absolutely can, and you will, right? It doesn't just disappear because you feel like it. So you've got to move this term, right? You want to move term by term away, right? So you want this term to be by itself, so you need to move this term. And to get rid of a negative 3x when you're adding it to 2y, so notice how these two terms are adding together. So here you want to just do the opposite of subtraction. So you want to add it to both sides, because a negative 3x, if you want to get 0, you just add 3x. So you want to add 3x. Negative 3x plus 3x is 0, so that cancels. You want to add 3x over here. That looks like a y. Right? So then you've got 2y equals your 3x plus your 6. You got a positive 3x and a positive 6, so you got a positive 3x and a positive 6. And now you're just one step away. Now you need to get the y by itself, so you just divide by 2. And here you want to divide everything by 2. Divide by 2, divide by 2. And you get y equals. Now I know that the 3 and the x are both in the numerator here, but when you have, when you're dividing multiple terms that are being multiplied by a number, you can just apply it to one of those pieces in the numerator. This is really 3/2 x plus 3. And if you don't believe me, then I will prove it to you real quick. So we had, you might say, well, why can you split this up like this? I thought that the 2 was also underneath the x here. Well, if you look here, this is 3 over 2, or 3x over 2, right? We agree that this is what we should do. I'm going to show you that 3/2 x is exactly the same thing. So this is 3/2 times x, right? But what's the denominator on x? What's the denominator on 12? What's the denominator on 6? Right? It's 6 over 1, 12 over 1, right? So this is x over 1. And when you multiply fractions, you multiply straight across, top times top, bottom times bottom, numerator and numerator, denominator, denominator, right? So you're going to have 3 times x, which is 3x, and then 2 times 1, which is 2. And that's why you get right back to where you started. 3x over 2, all right? So that's why this is definitely the same thing. Right? And we'll be doing this a lot, so get comfortable with that. Next, moving on, you've got 1/3 x plus 2/3 y equals 12. So go ahead and write that down if you've not done so. All right, so again, the main steps are exactly the same. You've got, if you looked over here, first you got rid of this x term by moving it to the other side. You'll do the same thing here. Then we divided by a number or got rid of the 2. We're going to do the same thing over here. It just looks more complicated. All right, so this is the term we want to get by itself, that 2/3 y. And so we need to subtract 1/3 x, because a positive 1/3 x minus a 1/3 x, it's like taking something and just taking it away, and you go back down to 0. So this cancels, and minus 1/3 x, and you're going to get that 2/3 y is equal to negative 1/3 x plus 12. Okay? Now, instead of dividing by 2 like we did here, what have we been doing to get rid of fractions whenever we need to get rid of them? Any of you guys remember? Now, you won't know if your other students around you have remembered, but if you remember, then honestly, I'm proud of you. You're doing good. But what you need to do is you need to, instead of dividing by 2/3, which absolutely will work, all right, 2/3 divided by 2/3 will cancel. But that's hard to understand when you're taking a fraction, dividing it by another fraction. So what we do instead is we multiply by the reciprocal, and that will cancel. So here, we multiply everything by the reciprocal. We multiply this term by the reciprocal. Let me put that down here. You multiply this term by the reciprocal, and we multiply this term by the reciprocal. All right, so you've got y equals, now what is negative 1/3 times 3/2? Well, you would multiply the top times the top, so that would be 1 times 3, which is 3. So I'll do that right here real quick. That is 3. And then the bottom times the bottom, which is 3 times 2, which is 6, and that is still negative. So 3 over 6 is 1/2, and it's still negative. So you get 1/2 x, and I'll go ahead and make little indications. So we multiply, and that's how you get this. All right, so you've got your y equals 1/2 x, and then you have to take 12 times the 3/2 as well. And just like we said that this was 6 over 1 and 12 over 1, we'll need that. Because to multiply a fraction times something, you treat it like it's a fraction times a fraction. So you've got 12 over 1 times 3 over 2. So take top times top. If you don't want to reduce the fraction outright, then we'll do it this way. 12 times 3 is 36, and then the bottom would be 1 times 2, which is 2. So that would be 36 over 2, which is, what, like 15, 16, 17, 18? 18? I should definitely know this. I think it's 18. All right, I'm just gonna check. 36 over 2. Yeah. All right, we're good. All right. So there's it's almost embarrassing, but I realize I don't care, and so it's like not embarrassing anymore. All right. So there are our answers: slope-intercept form, slope-intercept form. All right. Let's move on. Wow, how much more do we got? Oh my gosh. Oh my goodness. Oh jeez. All right, we need to speed up. We need to speed this thing up. Find the equations of the lines below in standard form. All right. So slope is 2. Passes through this point here. All right, so make an equation. Y equals mx plus b. They tell you m equals 2. So you plug that in for m. So y equals 2x plus b. This is like from the last lesson. You need to be able to find the equation of this line. So what did we do? Do you guys remember what we did to find the equation of the line given the slope and the point? After you did this, you plugged this in for x and you plugged this in for y. And so I'm going to plug 3 in for my x and negative 5 in for my y. And then simplify to find b, or solve for b. So you've got negative 5 is equal to 2 times 3 plus b. And so negative 5 is equal to 6 plus b. Subtract 6. I'll go ahead and write that down. And b is equal to negative 11. Okay? And so your equation of the line is y equals 2x minus 11. And you're just one step away from getting this into standard form, which is to get this number by itself, and so you just subtract 2x, and you get negative. Wow, did this happen? You get negative 2x plus y equals negative 11. Boom, done. All right, so basically, you just do everything we did to get it in slope-intercept form, and then just one step it away to get it into standard form. Okay. Again, find the equation in standard form. So we know how to get this into slope-intercept form. You need m, and then you need b. So find m, and that's the slope formula. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And so that's going to be, if I have this the first, this is the second, you've got y sub 2, 2 minus y sub 1, which is 7, and then x sub 2, negative 1, x sub 1, which is 5. You get negative 5 over negative 6, which is 5/6. All right, negative 5, negative 6, yep. So that's your m, and now you need to find b. So y equals your m x plus your b. And again, this is from last lesson. You plug this in, plug in either of these points you see fit into x and y. Now that I think about it, I'll do this one over here. I'll plug negative 1 in for x and 2 in for y. Okay, so I'm plugging in 2 for y, and I'm plugging in negative 1 in for x. Well, no. Okay, and so you're going to get 2 is equal to 5/6 times negative 1 plus b, and then solve that for b. You get 2 is equal to negative 5/6 plus b, because the negative 1 times the 5/6 gives you negative 5/6, and then you want to add the 5/6 to both sides to cancel. And b is going to equal 2 and 5/6. Now, most of the time, I absolutely hate mixed numbers, but to be honest, this time it doesn't bother me, because we don't need to do anything with it afterwards. So we got our m, we needed m, that was 5/6, and then we needed b, which was 2 and 5/6. That's odd, and this doesn't look like a 6, but it is, right? So that's y equals 5/6 x plus 2 and 5/6. And now you're one step away from getting this into standard form. You just subtract the 5/6 x to the other side. And then you get y is equal to negative, no. You get negative 5/6 x plus y equals 2 and 5/6. There's your answer. Okay. Moving on. Oh my god. All right. This is stuff you need to write, though. You can probably skip writing this and instead just write this. And you might want to like underline this in your notes and underline this in your notes, because you'll want to look back and do this. But this is what we'll do. This is what we're doing. We're going to find the x and y intercepts of a line in standard form and slope-intercept form. So all you need to do to find the x-intercept in an equation, or a linear equation here, is, plug in 0 for y and solve for x. So to get the x-intercept, you plug in 0 for y. To get the y-intercept, you plug in 0 for x. Okay, so let's do that. So here, you've got your equation. I want to find the x-intercept. So to find the x-intercept, you plug in 0 for y and solve for x. So when you plug in 0 for y here, what is 3 times 0? Well, it's just 0. So it just cancels the term out. This is why this is convenient to do. And you get 2x equals 9. And then you solve for x. And you're going to get to divide by 2, and you get I'll do that in a different color. You divide by 2, and you get that x equals 9/2. So something to point out, intercepts need to be given in an ordered pair format. So if this, like, you remember, you plugged in 0 for y. So on your ordered pair for your x-intercept, this is the value you got for x, 9/2. And the value you plugged in for y was 0. So that is your intercept. Right? That's your x-intercept. And then your y-intercept, you plug in 0 for x and solve for y. So you plug in 0 for x. So what's 2 times 0? Well, that's 0. And so you're just going to get 3y equals 9. And solve that for y. And you get y is equal to 3. And so what did we plug in for x? Well, we plugged in 0 for x, so it's going to be 0 in for x on the ordered pair, and we got out 3 for y. And so this is your y-intercept. There's your x-intercept, there's your y-intercept. You can do the same thing over here. Plug in 0 for x, plug in 0 for y, and see what you get. And we'll notice the difference in difficulty a little bit. So to find the x-intercept, plug in 0 for y and solve for x. So you get 0 equals 1/2 x plus 5. And now there's more work to do. Notice that we got a lot more work to do. So, well, not a lot more work, but more work. To get x by itself, this is just like a two-step equation. Subtract 5, and you get -5 equals 1/2 x. And then do you guys remember how you get rid of fractions? All right, we've done that several times now. You don't want to divide, well, you could divide by half, but that's hard to understand. So multiply by the reciprocal instead. So multiply by 2/1, which happens to be 2. So you're going to multiply by 2. And you get -10 equals x. So your ordered pair is what? You plugged in 0 for y, so I'm making my y 0, and you got -10 out for x. So there's your x-intercept. As for your y-intercept, you plug in, right, so you plug in 0 for x and solve for y. So y equals, this one's actually really easy. And this is another reason why this value here is the y-intercept, because when you plug in, or the y value of the y-intercept, so you plug in 0 for x, right, and you're going to get 1/2 times 0, which is 0. So just y equals 5. And so you get 0 in for x, 5 out for y. This is in slope-intercept form, so it should make sense that this value is the y-intercept. 5, 0, 5. Okay? Now, oh man. This is going to be probably your longest lesson yet. All right, so. Oh no. I got a text message from some random person thinking I'm somebody else. All right, so finding lines that are parallel and perpendicular. Parallel lines have the same slope. All right, same slope. That's the key words here. Parallel lines have the same slope, and perpendicular lines have an opposite reciprocal slope of each other. Now, opposite means that if it was positive, the perpendicular line will have a negative slope. Or if the original was a negative slope, the perpendicular line will have a positive slope. So opposite changes between positive and negative. Reciprocal flips it like the fraction upside down. So if the original had a slope of 12, the reciprocal would be 1/12. And then if you had like 3/4, the reciprocal would be 4/3. Okay? So that's what reciprocal means. So if you tag these together, opposite reciprocal, the opposite reciprocal of something like -1/2 would be, no, not equal to, it would be, right, the opposite would make it positive, and then the reciprocal would flip it, so it'd be +2, because it'd be 2/1, which is 2. All right, so that's just telling you guys about opposite reciprocal. So find the equation of the line that passes through that point there, -12, 1, and is parallel to this line here. Now, you have to start dissecting this information. You're trying to find the equation. That's the goal, to make an equation. and it passes through this point, so that's going to be relevant to us, and is parallel. Parallel. What does parallel mean? Parallel means that it has the same slope as this line here. What is the slope of this line? Well, it's in slope-intercept form, and so the slope is just the 2/3. This number here is the slope. So basically, this is really saying, and once you break it down, is find the equation of the line that passes through this point and has a slope of 2/3. And we've done this several times. You just use y equals mx plus b, and then you plug in 2/3 in for m, and then you plug in this for x, this for y. So you get 1 equals 2/3 times -12 plus b, and solve for b. And so to save you some time here, I'm going to work this out quickly. So this is going to be -8. So you're going to get a positive 1 equals -8 plus b. And then here you have to add 8 to both sides. And you can't quite see that. Add 8 to both sides, and you get 9 equals b. Okay, so you get y equals 2/3 x plus 9. There you have it. So all this information right here boiled down to, all this information right here told us was that the slope needed to be 2/3. Right, so don't let it be more complicated than it is. Okay, so here, find the equation of the line that passes through 4, 3, that is parallel, so same slope, to the other line which passes through these 2 points. So you've got line 1, which we're interested in, finding the equation of line 1 here, that passes through this point and is parallel to this line that passes through these points. So think about this and think about what you might want to do. Well, if our line is parallel to this line, then that means it has the same slope. Now, they don't tell us the slope in a convenient format, but they do give us 2 points on the line, which means you can find the slope given the slope formula. So you use this, given these 2 points, to find the slope of the second line here. So you're going to have 3 minus -1 over 1 minus 6, and that's 4 over -5. So there's your slope of the second line. So m is equal to -4/5. So this is now saying, find the equation of the line which passes through 4, 3, that is parallel to the line with the slope of -4/5. So if our line's parallel, that means we have to have the same slope. So this, again, just boils down to a situation where we know m and we know a point. So do all of this same stuff. So I'm just going to go ahead and breeze on through this. Y equals mx plus b. You're plugging in -4/5 in for m. Then you're plugging 4 in for x and 3 in for y. And then you're solving for b. Okay, and then you're going to get 3, 4, 5, 6, 6 and 1/5 equals b, or 31/5. All right, so then y equals -4/5 x plus 6 and 1/5. That's fine. Okay, done. Now, perpendicular. Last problem. Oh man, it's actually not going to be too much longer than our longest problem, our longest example so far. So find the equation of the line which passes through 6, -10 and is perpendicular, not parallel this time, but perpendicular to the line that passes through this. So the goal is still like find the slope and then do the perpendicular thing. So our line, since it's perpendicular to this line that passes through these points, we need to know the slope of this second line, because that's how we know we're like the opposite reciprocal here, because perpendicular is like opposite reciprocal slopes. So find the slope of the second line, and we're going to do that exactly the same way we did it up here. So you take y2, -4, minus y1, which is -6, over x2, which is 3, minus x1, which is 4. And you get 2 over -1, which is -2. Okay? Now that's your slope of your second line. Now, our line is perpendicular to this line here. So if m on this second line is -2, what is the relationship between this second line? What is the relationship between this second line's slope and our line's slope? Well, the slopes should be opposite reciprocals of each other. So the opposite reciprocal of 2 is, all right, the word opposite means it changes sign. So instead of -2, it is now +2. That's what opposite would do. Then the reciprocal flips the fraction. So it's 2 over 1 right now. So it becomes positive because it's the opposite, and it becomes 1/2 because it's the reciprocal. So our slope of our line is 1/2. So now that we know that it passes through 6, -10, and it has a slope of 1/2, you just do the same exact thing we've been doing. Y equals 1/2 x plus b. Plug in 6 and -10 for x and y. -10 equals 1/2 times 6 plus b. Solve for b. -10 equals 3 plus b. Subtract 3 from both sides. -13 equals b. And so y equals 1/2 x minus 13. If that was going for a little too fast for you, try to work the problem out on your own, and then watch me do it, and then see where you messed up at. All right, here's your homework. Pause the video to get a look at it, and sorry this was a couple minutes longer. I try to make them as short as I possibly can. I want you guys to have as much time to work on homework as you possibly can. And then, have at it.